Okay, so what we've got here is this trapezoid here. Rule 1, as is stated in your notes, says that it's equal to half the bases added together. Rule 2 says that it is parallel to both the bases. But now let's take a little bit of an application. Let's say that BC equals 2x plus 1. And then AD equals 16. And EF equals 11. I want you to figure out the value of x. If you use the formula, you just plug it in and solve it. Go ahead. That would be the formula that you're going to need. You could, instead of multiplying through by half, you could multiply everything by 2 here. And that would give you 22 equals 2x plus 17. Subtract the 17, you get 2x equals 5. And x is equal to 5 halves. All right, now we're going to jump more into what we're learning today and what we're learning in this unit. So this is just kind of a little basic refresher of something we needed to know from last unit. And we didn't quite learn it all, but I didn't feel that it fit appropriately in the spot we had last unit. So I wanted to add it into the beginning of this unit, okay? But what we're going to add in right now is some rules about ratios and the idea about ratios. So let's start with some basic ideas about ratios. Let's talk about basketball for just a minute. If a player shoots 40 shots, so 40 shots, okay? My pen's having some issues writing today, and I'm not sure why. So they take 40 shots in basketball. All right? But they only make 24 of them. So you got 24 made out of your 40 shots. That would be a ratio. A ratio is a comparison of two quantities. The two quantities here are the shots that you made versus the shots that you took. So the attempts is another way to say it. This is how you get your percentage. This is actually a really good percentage because it would be written as 24 over 40. It is a ratio. A ratio can be written in one of three ways. 24 divided by 40, 24 colon 40, or in place of the colon I could have the word 2. But in all reality, for our class, we're pretty much going to focus on this one here. You can work with it like a fraction, but it is not a fraction, specifically. It is comparing two specific ideas. Miles per hour is actually a ratio. So when we say 53 miles per hour, that's 53 miles over 1 hour. That's where miles per hour comes from. So this 24 to 40 can be reduced just like a fraction. In fact, that can be reduced to 3 divided by 8. Technically, if I wanted to, I could write this ratio as a decimal. This ratio would be 0.375 or 37. I apologize, this is wrong. It's not 3 over 8, it's 3 over 5. So 3 over 5 would be written as 60%. So the next thing we're doing is a proportion. And a proportion is basically, you take a ratio, you put an equal sign, you take another ratio, and you have a proportion. Okay? A basic proportion would be two actual known quantities. Let's say something like 2/3 and 4/6. Okay? I know for a fact that I could reduce this 4 over 6, but you're going to want to write this down. To check if ratios are proportional. To check if ratios are proportional. Do the cross product. The cross product means multiply the circled values. 2 times 6, 4 times 3. 12 equals 12. Once you've taken the cross product should be identical. If it is identical, the ratios are in proportion. That's the verbiage you want to use. The ratios are in proportion. All right, this brings us to our properties of proportion. These properties make life simple, so you want to commit them to memory. The first one we actually just went over, it's called the cross product. We're going to start everything if I have A divided by B is equal to C divided by D. Now you can see these in that box up top on your notes where it says property of proportion. All right? Our first property is the cross product, so it's property 1. And the cross product allows us to multiply the numerator of one side by the denominator of the opposite side of the equation. So that would be A D is equal to B C. So that is the cross product. It allows you to multiply A times D equals B times C. So if you have some sort of equation, you can solve it a whole lot faster. Number 2, the second rule is the reciprocal property. This is one of the handiest rules that I know. The reason this is a handy rule is how many of you do not like your x's or your variables being in the denominator rather than be in the numerator? Yeah, me too. I'm glad we all didn't raise our hands. All right. So if I have A over B equals C over D, what I can do with that I gotta cross that off. You can flip it over. B over A equals D over C. This is really handy when you get in the following scenario. Let's say I have 4 over 2x minus 1 is equal to 3 over 5. I personally don't like variables in my denominator, if I can help it. In fact, I'm going to change this a little bit. I'm going to change that 4 into a 1, and you're going to see how beneficial this really can be. Okay? So let's flip the whole thing over. That's the reciprocal property. So using that reciprocal property, I would now have 2x minus 1 equals 5/3. But what happened to the 1? Well, 2x minus 1 divided by 1 is 2x minus 1. So now by using the reciprocal property, I just was able to remove all the fractions on the left-hand side before starting to solve the problem. At this point, all I need to do is add 1 and divide by 2, and I'd be done. So it's a pretty quick process here. Okay, so rule number 3 is the BC switch property. The BC switch goes like this. Because B and C are numerators and denominators respectively, technically, I could multiply both sides by B, and that would cancel out this B, but it would put B in the numerator here. Then I could divide both sides by C, and it would cancel out that numerator, and it would put C in the denominator there. So what I have at this point is A over C is equal to B over D. This is most beneficial when A and C have common factors and B and D have common factors. It can make it nice and simple. Stuff gets done quickly. So let's look kind of how that would work. If I had a problem such as this, 4 divided by 5x minus 5 is equal to 8 over 5. Okay? The BC switch would allow us to switch those two locations. 4 divided by 8 would be 1/2. 5x minus 5 divided by 5 would be x minus 1. And that was just doing the BC switch instead of doing the cross product. Because the cross product would have given us 20 equals 40x minus 40. But by switching the locations of the 8 and the 5x minus 5, I can reduce it to something that's much more manageable without doing much work. Our last one is the most interesting of all the properties. It's the add the denominator property. If I add the same thing to both sides of an equation, I have technically kept it in balance. Can we agree to that? So let's look at this. If I originally had A divided by B is equal to C divided by D. Can I add 1 to both sides of this equation? Absolutely. Well, let's make it into common denominators. If I need a denominator of B on the left, 1 is now going to be A divided by B plus B divided by B. What's B divided by B, everybody? 1. So it's still 1, right? All I did was change the 1 to B divided by B. The same can be said for the right-hand side with our C divided by D. Then, our special rules for fractions state that if I have a common denominator, I add the numerators and leave the denominator the same. Well, that would give us A plus B divided by B is equal to C plus D divided by D. Mostly this is just a helpful property. We don't have a lot of instances where we use this, but it's mainly a helpful property, okay? So that's what we should be concerned with here. So as I was saying, the only rule for scale drawings, the only rule for scaling is the scale value and the actual value must be in the exact same location on each side of the proportion. So if you're dealing with a map, you would have your scale value over your actual value on the left, and then you would have your scale over your actual value on the right. And the one value you do not know is X or Y.